Hello and welcome to Life at Pulse. This is the second part of the IGCSE Chemistry Specimen paper from 2023, paper 2, the multiple choice paper. In our previous video we went up to question 9, so we will pick it up from here with question 10. So let's get started. Question 10, the diagram shows a circuit used to electrolyze aqueous copper 2 sulfate. Which arrows indicate the movement of the copper ions in the electrolyte and the electrons in the external circuit? So let's have a look at the second part of the question. First, the electrons in the external circuit. We know that electrons are negatively charged and therefore electrons flow from negative pole of the power supply to the positive pole, not to confuse with conventional current. The direction of conventional current is from positive to negative, but electrons flow from negative to positive because they are negatively charged. So in the external circuits, the electrons flow like this into the cathode, and then electrons will flow out of the anode into the battery. So the correct arrow that shows the electron flow is number 3. So that is the electron flow. Then ions. So we have copper sulfate, and the question is which arrow shows the correct direction of the flow of copper ions in the electrolyte. We know that copper ions have a positive charge, therefore they will go to the negative electrode. We know that electrons flow from negative in here, so here we have an excess of electrons. This is negatively charged. The cathode is the negative electrode, and therefore the copper ions will be attracted to the cathode. And so 2 is the correct arrow here for copper. So copper ions 2, electrons 3. Correct answer is C. Which row shows the waste products released from the exhaust of a vehicle powered using hydrogen-oxygen fuel cell? In a hydrogen-oxygen fuel cell, the two combine to form water, and that is the only product that is released from the exhaust from a car powered by a fuel cell. So the correct answer here is D. Which diagram is correctly labeled a correctly labeled reaction pathway diagram for an endothermic reaction? An endothermic reaction is a reaction that absorbs energy. Endo means in, so it takes energy in, and where does the energy go? It goes into the chemicals, and therefore the products have more potential energy or chemical energy than the reactants in an endothermic reaction. That means the products must be higher than the reactants, and now we just need to identify the correct diagram. So we have 2 options, A or B, and the difference here is the energies. The overall energy change of the reaction is the difference of energy between reactants and products. So from comparing the start to the end is the overall change. Therefore, this is correct, and the activation energy is the energy required to start the reaction. So we can see that for the reactants to react to form products, we need to put that much energy in at the start to get it all started, and then a little bit of energy will be released again to form the products. The reason for that is because bond breaking is an endothermic process, and bond forming or making is an exothermic process, and every reaction starts with bond breaking. The reactants need to be broken apart first into its individual atoms before they can recombine to form the products. In this case, the bond breaking is greater than the bond making energy, and therefore the overall energy change is endothermic energy gets absorbed. So A is the correct answer. Which changes are physical changes? Melting ice to form water. Yes, that is a physical change. Now the water, ice is water, liquid water is water, it's H2O, so physical change. Change of state, always physical change. Burning hydrogen to form water, so we can see that the identity of the substance changes. Burning, always an indication for a chemical change, so not 2. Adding sodium to water will cause a chemical reaction. You know this from maybe your lab experiments or from a video at least, where a sodium piece of metal forms a ball on the surface of the water, fizzes around, and eventually catches fire. So a chemical reaction as well. Boiling water to form steam. Again, we have change of state. Changing state, always physical change. So therefore, answer B is correct. The diagram shows an experiment to measure the rate of a chemical reaction. We have a dilute hydrochloric acid here, strip of metal down here, and we are collecting gas in an inverted measuring cylinder. Which change decreases the rate of reaction? What makes it slower? Adding water to the flask, heating the flask during the reaction, using more concentrated acid, using powdered metal. So we know that powdered metal overall will have a larger surface area than a large piece of metal, and increasing the surface area increases the rate of reaction because more metal will be exposed to the acid, so there are more particles that can collide, and therefore the rate of reaction will be higher. So it's not D. More concentrated acid, same thing. The particles are closer together, therefore we have a higher rate of collisions, and therefore we have a greater rate of reaction. So it's not C. Heating the flask during the reaction, adding heat increases the rate of reaction. Temperature increase causes rate of reaction to increase because particles move faster, and therefore there will be more collisions, or more frequent collisions. And additionally to that, when we increase the temperature, the particles have more kinetic energy. That means the collisions are more energetic, and there's a greater fraction of successful collisions as well. So temperature will increase the rate of reaction too. So that leaves us with adding water. So why does adding water decrease the rate of reaction? If we add water, it basically means that as soon as we add the acid gets diluted, and that means less concentrated. So that's basically the opposite of answer C. Therefore, it will decrease the rate of reaction. Which row describes the effect of increasing concentration and increasing temperature on the collisions between reacting particles? We just answered that as well in the previous question when talking about the different answer options here. So increasing the concentration means we have more collisions per second only, so it's either A or B. Again, because particles are closer together, but they don't have more energy. So more close together means it's a greater chance that they collide, so more collisions per second. Increasing the temperature will give us more collisions per second because particles move faster. So if they move faster, they're more likely to collide. And as well, because they have more kinetic energy, we will have more collisions with sufficient energy to react. So answer B is correct. Methanol is prepared by the reversible reaction shown. CO gas plus H. 2H2 gas gives us CH3OH, and this is a reversible reaction. So it can go in both directions, and the reaction will eventually reach an equilibrium state at some point where the rate of the forward reaction is equal to the rate of the reverse reaction, and the concentrations remain stable of the reactants and products. Which conditions produce the highest equilibrium yield of methanol? So we're looking for something that shifts the equilibrium over to the right side, and we are told that the forward reaction is exothermic. And whatever change, so this is called Le Chatelier's, you can quickly write that down. Le Chatelier's principle This is the most important thing you need to understand when it comes to changing the equilibrium position of a reversible reaction. It says that the equilibrium will react to a change in conditions by trying to reverse, it's the most important thing, it tries to reverse the initial change. So in other words, that means if we increase the temperature, then the equilibrium will shift in a way to decrease the temperature again. If we increase the pressure, the equilibrium will try to shift in a way to decrease the pressure. If we increase the concentration of a reactant, then the equilibrium will shift in a way to decrease the concentration of that reactant again. Not to its original value, but a little bit lower, basically. And so the first one is, the forward reaction is exothermic, highest equilibrium yield. So that means if we lower the temperature, then our system tries to increase the temperature, so it will favor the exothermic reaction, which is the forward reaction. So that means temperature low. Low temperature favor the exothermic reaction. The system will try to increase the temperature again. So it's either C or D. And pressure. So pressure will only affect gases. Now we know that gases can be compressed. So pressure in terms of gases is more or less the same as concentration, because if we increase the pressure, we push particles closer together and therefore they become more concentrated. So what we have to do is we have to count the number of gases, or the number of gaseous molecules on both sides of the equation. We can see we have 1 carbon monoxide and 2 hydrogen gas molecules on the reactant side. Therefore, on the reactant side, we have 3 moles of gases, and on the product side, we have only methanol as a single molecule. So here we have 1 molecule of gas. That means if we increase the pressure, our particles get closer together. Our system tries to decrease the pressure by reducing the number of gaseous particles. It can do that by reacting more reactants, forming more products, and that will cause the total number of gas particles in our whole system to be decreased. Therefore, when we increase the pressure, the equilibrium will shift to the right. So the correct answer here is C. When chlorine gas dissolves in water, a reaction occurs. Cl2 plus H2O gives HCl plus HClO. Which row of the table identifies the oxidation number for chlorine in the chlorine-containing species? So in an element, the oxidation number is always 0. Now the oxidation number basically tells us how many electrons our species has control over or has lost control over. Since elements have their normal number of electrons as written in the periodic table, that number is 0, and when they lose control over electrons, their oxidation number increases. That is because oxidation means loss of electrons, so the more electrons the substance loses, the more oxidized it becomes, and the oxidation number will increase. So if we look at HCl, now hydrogen basically always, in most cases, has an oxidation number of +2, and therefore chlorine must have an oxidation number of -1 here. If we have a neutral molecule, then the oxidation numbers must add up to 0, same as in ionic compounds, the charges. The oxidation numbers are very similar to charges. The difference is that we can assign oxidation numbers to covalent molecules as well. The oxidation numbers will show like which of the two molecules has more control, or atoms has more control over the electrons in the covalent bond. Hydrogen is always +1, we just said that. Oxygen is another rule that we need to know. Oxygen is always -2. And therefore, to make this 0, +1 -2, we need one more plus. So therefore, in this molecule, chlorine is +1. So these are our oxidation states. 0 in Cl2, -1 in HCl, and +1 in HClO. So therefore, D is the correct answer. 4 different solutions, J, K, L, and M, are tested with universal indicator. We see the different colors. Now, universal indicator, we know green is neutral, towards red, yellow, orange, red is acidic, blue, purple is alkaline. Which solutions are acidic? Red and orange, K and M, B. Which solution has the lowest pH? Here we need to know a little bit about acids and bases. So first of all, let's identify acids and bases. Well, ethanoic acid tells us it's an acid. Hydrochloric acid tells us it's an acid. Lithium hydroxide, and metal lithium tells us that must be a base. And ammonia, that's something that we need to know. Ammonia, NH3, is a base as well because it can accept a hydrogen ion. That's the definition of a base. Bases are hydrogen ions acceptors or proton acceptors and can form ammonium, the ammonium ion, NH4+. Therefore, ammonia is a base, and it's definitely not A, it's definitely not D. So it's B or C, lowest pH. So now we're looking for a strong acid, basically. Both of these acids have the same concentration, but one of them is strong, one of them is weak. We need to know that HCl is a strong acid. Ethanoic acid is a weak acid. Other examples of strong acids that you need to know are sulfuric acid, H2SO4, and the other strong acid that you need to know is nitric acid, HNO3. Now these are the 3 most important strong acids to know. All organic acids, ethanoic acid, methanoic acid, propanoic acid, and so on. These are all weak acids. Magnesium, calcium, strontium, and barium are group 2 elements. Group 2 elements follow the same trends in reactivity as group 1 elements. Which statements about group 2 elements are correct? Calcium reacts faster than magnesium with water. Barium reacts less vigorously than magnesium with dilute acid. Strontium oxidizes in air more slowly than barium. Let's have a look. So this is about reactivity series in a group. They follow the same trend as in group 1. That means you can check the periodic table. We see that the order of elements in this group is magnesium is over calcium, is over strontium, ST maybe, I'm not sure, and over barium. So, and we know that the reactivity in the group increases as we go down the group, becomes more reactive. So calcium will react faster than magnesium and water. Barium reacts less vigorously. Wait a moment. Yeah, so barium reacts less vigorously than magnesium. That is wrong, huh? Because barium is more reactive than magnesium. Strontium oxidizes in air more slowly than barium. That is correct. Oxidation is a chemical reaction. Barium is further down, so it will do that faster. So yes, strontium does react more slowly, so this one is correct too. So 1 and 3 only, answer C. Chlorine, bromine, and iodine are elements in group 7 of the periodic table. Which statement about these elements is correct? The color gets lighter down the group. It's the opposite. Now we know fluorine is almost a colorless gas. Chlorine is slightly light green. Bromine is a brown-orange liquid, and iodine is a almost black, deep purple solid. So the color gets more dark down the group. The density decreases down the group. No? This is a gas at room temperature, gas at room temperature, liquid at room temperature, solid at room temperature. Therefore, the density will increase going down the group. They are all gases at room temperature. That is wrong. And they are all nonmetals. That is correct. Which row describes the properties of typical transition metal? Transition metals have high melting points. Yes, absolutely. So it's either A or B. They have variable oxidation numbers. Yes, this is why, for example, when we have iron oxide, we specify it more as something like iron 3 oxide. No? So this is the oxidation, tells us the oxidation state, which means the iron in here is a 3+ ion. And that's why we add these numbers in the names. So therefore, yes, they do have variable oxidation numbers, because there is not one more example. There's as well iron 2 oxide, which has the Fe2+ ion. In both cases, oxygen is always going to be 2-, and it's in group 6, so that will stay the same. So therefore, the formula is Fe2O3 here. Cross the numbers to figure out the formula, and iron 2 oxide is just FeO. So can act as a catalyst? Yes, that must be correct, and that is correct. These are the typical properties of transition metals. And the other property which is left out here that you need to know about transition metals is that they form colored compounds. Which statement about the noble gases is correct? Noble gases are diatomic molecules. Noble gases are reactive gases. Noble gases have full outer electron shells. And the noble gases are found on the left-hand side of the periodic table. I hope you know this. The correct answer here is that they have a full outer electron shell. They're found on the right side of the periodic table, not the left. And they are the least reactive elements in the periodic table, and they form monoatomic. They are monoatomic, no, not molecules. They just occur as individual atoms because they're stable. They have a full outer shell. They don't need to form any bonds. What is a property of all metals? Conduct electricity. They're hard. They have low melting points. They react with water. The correct one here is that they conduct electricity. All metals have delocalized electrons because of their metallic bonding, therefore all of them conduct electricity. Most metals are hard, but not all of them. Group 1 metals are relatively soft. They can be cut with a knife, so it's not that. Low melting points. Then again, group 1 have relatively low melting points, yes, but something like a transition metal has an extremely high melting point. And most metals react with water, but not the unreactive metals, such as silver, gold, or platinum, or copper. Which statement explains why aluminium is used in the manufacture of aircrafts? It conducts heat well. That's not something that's needed in aircrafts. It has low density. That is probably the correct answer, because we want aircrafts to be light. It's a good insulator. No, it's not a good insulator. Metals conduct heat well, so they don't insulate. It is easy to recycle. Not really, so yes, that is the important property for airplanes. The section of the reactivity series shown includes a newly discovered metal X right here. The only oxide of X has the formula XO, so that means it must be a 2+ metal ion, because oxygen is always 2-. which equation shows a reaction which occurs. So it is above copper in the reactivity series. So that means copper will not react with it, because the ionic state is the more stable state. That's where the atoms want to be in. So copper is less reactive, therefore it cannot give electrons to our metal. This is wrong because it's not balanced. We know that it must form a 2+ ion, so it must be a 1-to-1 ratio, not a 2-to-1 ratio. Therefore B is wrong. C, it is less reactive than iron, so it will not react with iron oxide. No, this is basically the same explanation as up here. The only difference is that we have the oxygen here, but what's actually happening here is that we could just leave out the oxygen. Charges are wrong as well. No? So it must be D. It will, yeah, it does react with an acid because it is above hydrogen in the reactivity series, so therefore it will react with an acid. Which metal compound produces a gas that turns lime water milky when it is heated with a Bunsen burner? That must be the carbonate, because when we heat a metal carbonate, it decomposes into the metal oxide plus carbon dioxide, and the carbon dioxide bubbled through lime water will turn it milky. You know, this is the test for carbon dioxide. All the others, nitrate, sulfate, nitrate, they don't produce carbon dioxide, so therefore they wouldn't turn the lime water milky. And with that, we can have a break here, and we will go over the last 13 questions in part 3 of the video. Have a good day, and I see you in the next screencast.